What nobody tells you about. How the solar system actually moves. Tonight, we're going to take something you've understood your whole life and turn it completely upside down. Not metaphorically, literally, because the picture of our solar system that lives in your head, the one with the sun sitting still at the center while the planets trace their neat ellipses around it, is wrong in a way that most people never discover. Not slightly wrong, not wrong in some technical footnote kind of way, wrong in a way that changes the entire shape of the thing, wrong in a way that makes the real solar system look almost nothing like the diagram you memorized in school. Because here is what nobody tells you. The sun is not sitting still. It never was. The planets are not simply orbiting a stationary point in space. They are following the sun as it hurtles through the galaxy at a speed that would make your head spin. And the paths they trace as a result, the actual paths these worlds carve through three-dimensional space, are not the flat ellipses of the textbook diagram. They are something else entirely. Something that has a name, a shape, and implications for how you understand the solar system, your place in it, and the nature of motion itself. If you've ever found yourself staring up at the night sky and wondering what's actually happening up there, not the simplified version but the real version, then stay with me, because what we're about to go through is one of those rare things that will actually change how you see the world every time you step outside and look up. A like or subscribe helps this channel keep doing exactly this kind of deep exploration, and it genuinely makes a difference. Now, let's get into it. Let's start where the confusion starts. In school, you were shown a diagram. You know the one. The sun sits right in the middle of the page, glowing yellow and important, and the planets are arranged around it in concentric rings. Maybe there were little arrows showing the direction of orbit. Maybe the sizes were roughly to scale. Maybe they weren't. But the fundamental geometry was always the same. The sun at the center, the planets going around it in flat circles or slightly squashed ellipses. Everything neat, everything orderly, everything happening on a single plane, as if the solar system were a clockwork mechanism laid out on a table. That diagram has been in textbooks for generations. It appears in documentaries. It decorates the walls of science classrooms around the world. And it is, without question, useful. It tells you the order of the planets. It gives you a rough sense of their relative distances. It illustrates the concept of an orbit in a way that's immediately clear and intuitive. But it is doing something to your brain that you probably haven't noticed. It is convincing you that the sun is the fixed center of the universe, that it sits there like a nail hammered into the fabric of space, and everything else swings around it. That motion in the solar system means going around that stationary central point, round and round, year after year, forever. And none of that is true. The sun is moving. It has always been moving. Right now, at this exact moment, our sun is traveling through space at approximately 230 kilometers per second. That's not 230 kilometers per hour. That's 230 kilometers per second. In the time it took you to read that sentence, the sun moved roughly 1,000 kilometers from where it was when you started. It is flying through the Milky Way galaxy at a speed so enormous that the fastest spacecraft humanity has ever built would look almost stationary by comparison. The sun is orbiting the center of the Milky Way galaxy. Just as Earth orbits the sun orbits the galactic center, a journey so vast that it takes our star approximately 225 to 250 million years to complete a single lap. Astronomers have a name for this period of time. They call it a cosmic year or a galactic year. In the entire history of complex animal life on Earth, roughly 600 million years, the Sun has completed less than 3 full orbits of the galaxy. In the entire history of the solar system, about 4.6 billion years, it has gone around roughly 20 times. Now think about what this means for the planets. If the Sun is moving through space at 230 kilometers per second, then the planets, which orbit the Sun, are not just going in circles around a fixed point. They are going in circles around a point that is itself racing through space. Their actual paths through the galaxy, the lines they draw through three-dimensional space as you watch from outside the Milky Way, are not ellipses at all. They are spirals. Stretched, sweeping, three-dimensional spirals that wind through the galaxy like the threads of a cosmic screw. Imagine watching a child on a merry-go-round, while the merry-go-round itself is on a truck driving down a highway. From the side of the road, the child isn't just going in a circle. The child is tracing a looping, winding path through space, moving forward with the truck while also spinning around the center of the ride. The shape you'd see if you drew that path on paper is a cycloid, a series of loops that travel forward even while they curve back on themselves. The solar system works on exactly this principle, except in 3 dimensions and at vastly greater scales. The planets are on a merry-go-round. The merry-go-round is on a truck. The truck is the Sun, barreling through the Milky Way at 230 kilometers per second. And the path that each planet traces through the galaxy is a helix, a spiral coiled around the Sun's trajectory, winding forward through space as the Sun carries the whole system with it. This is the thing that the flat diagram cannot show you, not because the people who drew it were being careless, but because a flat diagram on a flat page simply doesn't have the dimension required to represent it. You can show an orbit. You can show a circle or an ellipse around a central point. But you cannot show a 3-dimensional helix on a 2-dimensional surface without making the picture so complicated that it stops being useful as a teaching tool. So the motion of the Sun through the galaxy gets dropped. It gets simplified away. And in doing so, something fundamental about the real behavior of the solar system disappears from the picture. So let's talk about what a helix actually looks like, because the word might be abstract at first. A helix is the shape of a coiled spring. It's the shape of the thread on a bolt. It's the shape of the DNA double helix, the structure that carries genetic information in every living cell on Earth. A helix is what you get when you take circular motion and add a direction of travel. If you're walking forward while spinning in a circle, your path through space is a helix. If you're a planet orbiting the Sun while the Sun flies through the galaxy, your path through space is a helix. For Earth, the helix works like this. Earth orbits the Sun once every 365 days, covering a roughly circular path. Meanwhile, the Sun is moving through the galaxy at 230 kilometers per second. So, Earth's orbit is not a closed loop that returns to its starting point. In the time it takes Earth to complete one trip around the Sun has carried the entire solar system roughly 7.25 billion kilometers forward through the galaxy. Earth traces a spiral that advances through space as it curves, never returning to the exact point where it started, always moving forward into new territory. If you traced Earth's path for a single year and then looked at that, line from the side, you'd see a single loop of the helix, a coil that travels forward as it curves. If you traced it for 10 years, you'd see 10 loops, a coiled spring 10 turns long. If you traced it for the entire history of the planet, for 4.5 billion years, you'd see a spring of incomprehensible length, wound billions of times over, stretching billions of light-years forward along the sun's path through the galaxy. Every planet traces its own helix. Mercury, orbiting the sun in just 88 days, winds a much tighter, faster helix than Earth does. It makes more loops per unit of distance traveled, a tightly wound spring. Neptune, orbiting the sun once every 165 Earth years, traces a much wider, more slowly coiling helix, a loosely wound spring. But all of them are helices. All of them are spiraling through the galaxy, never returning to where they began, always moving forward through space. Now, here's where it gets even more interesting, because the sun isn't moving in a straight line through the galaxy. Nothing in the galaxy moves in a perfectly straight line. Everything is curving, everything is in orbit, everything is following the complex gravitational geometry of a structure containing hundreds of billions of stars and vast amounts of invisible dark matter. The sun's path through the galaxy is itself a curve, a sweeping arc that bends as the sun orbits the galactic center over those 225 to 250 million year cycles. So the planet's paths are not simple helices wound around a straight line. They are helices wound around a curve, a spiral within a spiral. The planets are tracing helical paths around the sun's trajectory, and the sun's trajectory is itself curving through the galaxy on the timescale of hundreds of millions of years. The actual shapes the planets are drawing through three-dimensional space are astonishingly complex. They are multi-layered spirals embedded within spirals, loops within curves within arcs, all of it sweeping forward through a galaxy that is itself moving through the local universe at hundreds of kilometers per second. This is the real geometry of the solar system, not a flat disk with circular orbits. A dynamic, three-dimensional, endlessly advancing coil of worlds wound around a star that is itself a traveler, never stopping, never returning, always heading somewhere new. Let's talk about the speed for a moment, because the numbers are genuinely staggering, and I don't think most people have ever sat with them long enough to feel what they actually mean. The sun moves through the galaxy at 230 kilometers per second. Earth orbits the sun at about 30 kilometers per second. So at any given moment, Earth's total velocity through the galaxy is the combination of these two motions, roughly 250 kilometers per second in the direction the sun is heading, modulated by the 30 kilometers per second of Earth's own orbital motion, adding to or subtracting from that depending on where we are in the orbit. At some points in our orbit, we're moving in roughly the same direction as the sun through the galaxy. So our combined speed is around 260 kilometers per second relative to the galactic center. 6 months later, our orbital motion is carrying us in roughly the opposite direction, so our combined speed drops to around 220 kilometers per second. But let's focus on just the sun's motion for a moment. 230 kilometers per second. That is 828,000 kilometers per hour. That is roughly 0.07% of the speed of light. In one day, the sun travels about 20 million kilometers through the galaxy. In 1 year, it travels about 7.25 billion kilometers. In one lifetime, say 80 years, The Sun will travel roughly 580 billion kilometers through the galaxy. In that same lifetime, it will travel enough to cross the distance from here to our nearest neighboring star multiple times over. Right now, as you're reading or listening to this, you are moving through the galaxy at about 230 kilometers per second. You've probably never felt it. You have no sensation of this motion because everything around you, the air, the ground, the planet, the solar system, is all moving with you. Motion only feels like motion when there's a reference point that isn't moving the same way. You feel Earth spinning because the atmosphere lags slightly and creates wind. You feel the planet moving when you look up and see the stars shift over the course of the night. But the Sun's motion through the galaxy produces no sensation for us at all. We are carried along in it completely, passengers on a ship so large that the journey is imperceptible from inside. And this has been true for the entire history of life on Earth. Every single organism that has ever lived, every bacterium, every dinosaur, every human being who ever drew breath, has lived their entire existence on a world that was simultaneously spiraling around the Sun and flying through the galaxy at 1/3 of a million kilometers per hour. None of them felt it. None of them knew it until very recently. The universe moves us without asking permission and without providing sensation. Now, let's think about what this does to the concept of place. Where is Earth exactly? Not in terms of its address within the solar system, third planet from the Sun, about 150 million kilometers out. That's all true. But where is the solar system? Where is the solar system in the galaxy, and where will it be? The answer is that the solar system doesn't have a fixed address in the galaxy. It's passing through. Right now, we're in a region of the Milky Way called the Orion Arm, or the Local Arm, a minor spiral feature between two of the galaxy's larger spiral arms. We've been here for a while. We'll be here for a while longer. But over millions of years, the Sun's orbit carries it through different regions of the galaxy, past different stellar neighborhoods, through regions of different stellar density, and different concentrations of gas and dust. This matters more than you might think. The galaxy is not uniform. Some regions are dense with stars and gas clouds. Others are relatively empty. Some regions are more dangerous, closer to the galactic center where radiation is more intense, or near regions where supernovae occur more frequently. The Sun's journey through the galaxy over billions of years has taken it through all kinds of different cosmic environments, and the solar system Earth rides in has experienced all of those environments. There have almost certainly been times in Earth's past when the solar system was in a denser region of the galaxy, passing closer to other stars, experiencing stronger gravitational perturbations, maybe receiving increased flows of comets nudged out of the outer solar system by those gravitational disturbances. And there have probably been times when we were in quieter, emptier regions, more isolated, more stable. The history of life on Earth, the extinctions, the periods of dramatic change, the long, quiet stretches, may be partly written by where the solar system happened to be in its galactic journey. Some researchers have looked at the timing of mass extinctions in Earth's geological record and compared it to estimates of the Sun's galactic orbit, wondering whether passages through denser regions of the galaxy might correlate with increased comet impacts or enhanced cosmic radiation. The evidence is intriguing, but not conclusive. The galaxy is not a threat to life on Earth in any simple or immediate sense, but it is a context. The solar system doesn't exist in isolation from the galaxy. It moves through it, is shaped by it, is part of it. Let's go back to the helix, because there's more to say about its shape and what it reveals. One of the things that surprises people when they first encounter this idea is the question of direction. The helical path of the planets through the galaxy. Which way does it wind? Does it spiral away from the ecliptic plane, or does it stay within it? The answer is that the helix winds around the Sun's path through the galaxy, which is approximately in the plane of the Milky Way's disk. The ecliptic, the plane of the planet's orbits, is tilted at about 60 degrees relative to the galactic plane. So the helix traced by each planet is a coil that's tilted at about 60 degrees to the direction of travel. The coils don't lie flat along the path. They're angled, canted, twisted relative to the direction of motion. If you tried to draw this, and people have with some beautiful results, you'd see the Sun's trajectory as a curved line sweeping through space and wound around it. At an angle of roughly 60 degrees to that line, the helical paths of all the planets, each one a coil of different size and pitch, all winding together in a complex braided structure. Mercury's tight, fast coils closest in. Neptune's vast, slow, widely spaced loops at the outside. Earth's coils somewhere in the middle, one loop per year, advancing about 7 billion kilometers with each turn. The whole structure is dynamic. It changes shape over time as the solar system's orientation relative to its direction of travel shifts. Over the course of the Sun's 225 million-year orbit of the galaxy, the ecliptic will slowly rotate relative to the galactic plane, changing the angle of the coils. What is a 60-degree tilt now was a different tilt millions of years ago, and will be a different tilt millions of years from now. The helix structure of the solar system is not static. It evolves. There's also another layer of motion that adds further complexity. The Sun doesn't just orbit the galactic center. It also bobs up and down through the plane of the Milky Way as it goes. The galaxy's disk has a gravitational midplane, a surface of maximum star density, and the Sun oscillates above and below this midplane as it orbits. The amplitude of this bobbing is estimated at about 200 to 300 light-years above and below the midplane, and the period of one full up and down oscillation is roughly 60 to 70 million years. So the Sun's path through the galaxy is not a simple flat curve. It's a three-dimensional path that spirals around the galactic center while simultaneously oscillating up and down through the disk. And wound around this three-dimensional path are the helical orbits of the planets, themselves oscillating with the Sun. The actual trajectories of the planets through the galaxy are extraordinarily complex curves, sweeping, spiraling, bobbing structures that no flat diagram could ever capture. When astronomers talk about the Sun's motion through the galaxy, they typically distinguish between three components. There's the circular motion, the part that carries the Sun around the galactic center at 230 kilometers per second. There's the peculiar motion, the small deviation from a perfectly circular orbit that gives the Sun a slight drift relative to the stars in its immediate neighborhood. And there's the vertical motion, the up and down bobbing through the galactic plane. All three of these are happening simultaneously, all the time. The Sun is always circling, always drifting slightly sideways, always oscillating up and down, all at the same time. And every planet in the solar system is doing all of this with it, while simultaneously orbiting the Sun. The flat diagram in the textbook shows you none of this. It can't. It's a flat diagram. The full reality requires at least 3 dimensions, and ideally 4, since the 4th dimension of time is essential to understanding how these paths evolve. The diagram is a useful fiction, a simplified model that captures one layer of truth while hiding several others. Now, you might be wondering whether any of this actually matters for day-to-day life, or even for the practice of science. Do astronomers need to account for the sun's motion through the galaxy when they're tracking planets or planning spacecraft missions? And the answer, interestingly, is not usually. For the purposes of planning a mission to Mars or calculating the position of Jupiter next year, the sun's motion through the galaxy is irrelevant. The entire solar system is moving together, so the relative positions of the planets to each other and to the sun are unaffected by the galactic motion. The helix is the right picture for understanding the absolute positions of the planets in the galaxy, but for navigating within the solar system, you can treat the sun as stationary, and everything works perfectly well. This is actually an important point about physics. It's called the principle of Galilean relativity, or more formally, the equivalence of inertial reference frames. The laws of physics are the same in any reference frame that's not accelerating, so you can choose to do your calculations in a reference frame where the sun is stationary and Earth orbits it, or in a reference frame where the galactic center is stationary and the sun orbits that, or in a reference frame where the cosmic microwave background is stationary and the entire Milky Way is moving. All of these reference frames are equally valid for doing physics. The answers you get for observable quantities, like where a spacecraft will be at a given time, are the same regardless of which frame you use. The reason the helix matters isn't for spacecraft navigation. It matters for understanding what the solar system actually is, for understanding its history, for understanding its relationship to the rest of the galaxy, for understanding the true nature of the motion that the flat diagram represents. It matters because the true picture is more beautiful, more complex, and more humbling than the simplified one. And understanding it changes your sense of what it means to be here, on this planet, in this solar system, at this moment. Let's think about the implications for Earth's history specifically, because they are genuinely remarkable. Every single day in Earth's 4.5 billion year history, the planet was somewhere it had never been before, and would never be again. Not just in a poetic sense, literally, because the sun is always moving forward through the galaxy, and the planets are winding around that forward motion in their helical paths. No planet ever returns to the same point in three-dimensional space. The orbit around the sun is a closed loop in the reference frame of the solar system, but it's an open spiral in the reference frame of the galaxy. This means that Earth has occupied an essentially uncountable number of distinct locations in the galaxy during its existence. It has passed through different neighborhoods, different densities of stars and interstellar medium, different cosmic environments. The Earth of 4 billion years ago, when the first life was stirring in the primordial oceans, was in a completely different part of the galaxy from the Earth you're on right now. Not just a different place within the solar system, a different place in the galaxy entirely. Billions of light years away from where we are now when measured along the sun's accumulated path through the Milky Way. There is another way to think about this that I find particularly striking. You've probably heard the saying that we are made of stardust. that the atoms in your body were forged in the cores of stars that lived and died before the sun was born. And that's true. The carbon in your cells, the oxygen you breathe, the iron in your blood, all of it was cooked inside earlier generations of stars and scattered through the galaxy in supernova explosions, eventually becoming part of the molecular cloud that collapsed to form the solar system. But here's the extension of that idea that rarely gets stated. Those earlier stars, the ones that made your atoms, were not where we are now. They were somewhere else in the galaxy when they lived and died. The atoms in your body have traveled. They've been blown through interstellar space in supernova shockwaves. They've drifted through molecular clouds. They've condensed into a protoplanetary disk. They've been incorporated into a planet. And they've been riding that planet through the galaxy for 4.5 billion years of helical motion, never pausing, never returning, always sweeping forward. The atoms that make you up have been to places in this galaxy that the rest of you will never go. You are the current address of matter that has had an extraordinary journey. And that journey continues right now at 230 kilometers per second as you read this. Let me address something that sometimes comes up when people first encounter the helical model of the solar system. There's a visualization that circulated widely on the internet a few years ago, sometimes called the vortex model, that showed the solar system as a kind of comet-like structure, with the sun at the leading edge and the planets trailing behind it in a helical path. It was a striking visual, and it captured something true about the helical nature of the planets' paths. But it also got some things wrong, and it's worth being clear about what the actual science says. The sun does not lead the planets like a comet dragging its tail. The planets don't trail behind the sun. In the reference frame of the solar system, the planets orbit the sun in roughly the same plane as always, which happens to be tilted about 60 degrees to the direction of the sun's motion through the galaxy. This means that as the solar system moves forward, the planets are not behind the sun. They are all around the sun, above, below, ahead, behind, in an orbit that is tilted relative to the direction of travel. At any given moment, some planets are ahead of the sun in its galactic journey, and some are behind it, depending on where they are in their orbits. The structure is a tilted coil, not a trailing tail. The vortex video also implied that the sun's galactic motion was a kind of cosmic secret that mainstream science was hiding or ignoring. That's not the case at all. The sun's motion through the galaxy has been known and studied for well over a century. It shows up in textbooks, in scientific papers, in everything from undergraduate astronomy courses to the most advanced astrophysics research. The reason it doesn't appear in the flat solar system diagram isn't that anyone is concealing it. It's simply that the diagram is designed to show the orbital structure of the solar system in the solar system's own reference frame, where it's most useful and most clear. The real insight isn't that science has been hiding the sun's motion. It's that the simplified diagram, however useful, leaves out a layer of reality that is genuinely magnificent. And understanding that layer adds something to the picture, rather than undermining the parts that were already there. Now, let's take this one step further, because the sun's motion through the galaxy is just one level of a nested set of motions that the solar system is embedded in. The galaxy itself is moving. The Milky Way is not floating in isolation in the universe. It's part of a structure called the local group, a cluster of roughly 50 galaxies held together by their mutual gravity. The local group spans about 10 million light-years, and includes, along with the Milky Way, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf galaxies scattered around them. And the Milky Way is moving through the local group. It's falling toward Andromeda, in fact, drawn by Andromeda's gravity. The two galaxies are approaching each other at roughly 110 kilometers per second and are expected to collide and eventually merge in about 4.5 billion years. But even the local group is moving. It's falling toward a larger structure called the Virgo cluster, a dense collection of over 1,000 galaxies about 53 million light-years away. The Virgo cluster anchors an even larger structure called the Virgo supercluster, of which the local group is a minor outlying member. And even beyond that, there is a still larger structure, Laniakea, a supercluster of superclusters spanning roughly 500 million light-years that was only fully mapped in 2014. The Milky Way lies near the outer edge of Laniakea, slowly flowing toward its center of mass. So here's the full picture of the nested motions that you are personally embedded in at this moment. Earth is orbiting the Sun at about 30 kilometers per second. The Sun is orbiting the galactic center at about 230 kilometers per second. The Milky Way is moving through the local group at roughly 90 kilometers per second toward the center of the local group. The local group is falling toward the Virgo cluster at roughly 300 kilometers per second. And the entire local region of the universe is flowing toward the center of Laniakea at several hundred kilometers per second. Add all of these up, and your total velocity relative to the cosmic microwave background, the benchmark of rest in the universe, is somewhere around 600 kilometers per second. 600 kilometers per second. You are moving at 600 kilometers per second right now without feeling a thing. That is 2.16 million kilometers per hour. That is fast enough to cross the entire Atlantic Ocean in about 3 seconds. That is roughly 0.2% of the speed of light. And none of the flat diagrams that showed you the solar system, not one of them, captured any of this. They showed you a stationary sun, a flat disk of planets, a tidy arrangement that suggested stillness at the center and orderly motion around it. The real picture is a set of spirals, within spirals within spirals, all embedded in a river of galactic motion, all nested inside a flow of intergalactic drift, all of it tumbling together through a universe that has no center and no preferred direction. The solar system isn't a clock on a wall. It's more like a spinning top that's been thrown from a moving train that's on a moving planet that's orbiting a moving star. Every part of it is moving. Nothing in it is still. The stillness of the sun in the diagram is a convenient fiction, a frame of reference chosen for its usefulness, not a description of what is actually happening. And this matters for how we understand time as well. When we say that Earth is 4.5 billion years old, we mean 4.5 billion years of orbits around the sun. But those orbits have not been going in circles through a fixed space. They have been spiraling forward through the galaxy, covering an enormous volume of three-dimensional space over those 4.5 billion years. The history of Earth is not just a timeline. It is a path, a helical, spiraling, galactic-scale path through space that stretches for billions of light years if you uncoil it. Similarly, when you think about the future, you can think about it not just as a line of time stretching forward, but as a path through space. The next million years of Earth's existence will take the planet on a helical path that covers roughly 230 light-years of galactic distance. The next billion years will cover roughly 230,000 light-years. In a billion years, Earth will have spiraled through a region of the galaxy that is larger than many of the satellite galaxies orbiting the Milky Way. The universe is not a stage on which events happen. It is itself one of the actors. Space is not empty backdrop. It is a dynamic, evolving medium through which the solar system moves, and the nature of that medium changes as the system moves through it. The interstellar environment the solar system is in right now is not the same as the one it was in 100 million years ago. It's not the same as the one it will be in 100 million years from now. There is something unexpectedly moving about all of this. We tend to think of home as a fixed place, a location, a set of coordinates that stays the same while other things change. And in one sense, that's true. Earth's position relative to the Sun and the Sun's position within the solar system are stable and consistent in ways that make the solar system feel like a permanent, anchored home. But in another sense, home has always been moving. It has never been stationary. It has always been traveling through the galaxy, visiting new regions, leaving old ones behind. The solar system is not a fixed address. It is a journey, a continuous, never-repeating, always advancing journey through the Milky Way and through the larger universe beyond it. You were born in motion. You live in motion. Every breath you've taken while flying through the galaxy at nearly 1,000,000 kilometers per hour. Every meal, every dream, every moment of quiet sitting by a window and looking at the sky, all of it has happened at high speed, in motion, on a world that was somewhere it had never been before and would never be again. The flat solar system diagram captured one important truth. The planets orbit the Sun in a consistent pattern that can be understood, predicted, and navigated. That truth is real and it matters enormously. But it missed another truth, just as important, just as real. The Sun is a traveler. The solar system is a traveler. And everything that has ever happened on this planet has happened while we were in transit, spiraling through a galaxy that is itself in motion, embedded in a universe that is expanding in every direction at once. The next time you see that diagram, the Sun in the middle, the planets going around it, you'll know what to add to the picture in your mind. The entire structure is moving, sweeping forward through the galaxy like a coil of worlds wound around a flying star. Every planet's orbit is not a closed loop, but an open spiral, advancing through space, never returning to the same point, always new. The solar system is not a mechanism sitting on a table. It is something more like a dancer in motion, one hand tracing circles in the air, while the whole body sweeps across the floor. The circles are real. The motion is real. And neither one makes sense without the other. And that dancer, that spiraling, helical, galactic-scale structure of 9 worlds around a flying star, is where you live. Not on a flat disk in a fixed position in space, on a world that is spiraling through the Milky Way right now, at this moment, as you finish reading this sentence, having already moved another 230 kilometers forward into territory the solar system has never visited before. There's no going back to where we were. There never was. The path only goes forward. And somehow, knowing that, the night sky looks a little different than it did before. Not just a ceiling above you, but a landscape around you. A galaxy you are moving through. A journey you are on, whether you feel it or not. If this kind of thing lights something up for you, a like or subscribe means the world and helps keep this going. Take one more look at the stars tonight. You're not standing still under them, you're flying through them, and you have been since the moment you were born. Let's go even deeper, because there's a question buried inside everything we've discussed that most people never think to ask. If the planets are all tracing helical paths through the galaxy, winding around the sun's trajectory, do they ever come close to each other in that three-dimensional sense? In the flat diagram, the planets have clear lanes, their orbits nested inside each other like rings on a target. But in three-dimensional galactic space, where each planet is tracing its own helix at its own angle and pace, how do those helices relate to each other? The answer is that they're all wound around the same central thread, the sun's path through the galaxy, so they're all coiled together in a kind of braided structure. Mercury's tight, fast helix is wound around the same trajectory as Neptune's vast, slow helix, both coiling around the line the sun is drawing through space. At any given moment, the planets are spread around the sun in their usual arrangement, some on one side, some on the other, some above the ecliptic, some below it. But the key thing is that their positions relative to the sun remain as they always have been. The helix is a feature of their absolute position in the galaxy, not of their position relative to the sun. This is a subtle but important distinction. In the solar system's own reference frame, everything looks just like the textbook diagram. The planets orbit the sun in their familiar ellipses. Nothing looks helical. The helix only appears when you step outside the solar system and watch from a fixed point in the galaxy, watching the whole structure fly past you. From that vantage point, the planets don't seem to orbit the sun in closed loops. They seem to weave back and forth across the sun's path in long, winding curves. This is similar to what you see when you watch a spinning wheel rolling down a road. A point on the rim of the wheel traces a cycloid, that series of loops we mentioned earlier. But from the perspective of someone sitting on the wheel, the point is just going in a circle. The cycloid is the view from outside. The circle is the view from inside. Both are true. Both are valid. They are just different perspectives on the same motion. Our everyday experience of the solar system is the view from inside the wheel. We see the planets going around the sun. We see the familiar orbits. We don't feel the forward motion because we're part of it. But the view from outside the wheel, the view from a fixed point in the galaxy watching the solar system fly past, would reveal the helical reality that the textbook diagram never shows. Now, there's something else worth talking about that connects directly to this idea of nested motions and different reference frames. It's the question of what the sky looks like from different points in the solar system's journey, because the sun's position in the galaxy changes over time. The night sky as seen from Earth is not the same as it was millions of years ago, and not the same as it will be millions of years from now. The stars are not fixed. They have their own motions through the galaxy, their own peculiar velocities that slowly change their positions relative to us over time. The constellations, Orion, the Big Dipper, Cassiopeia, these are patterns that exist because of the current relative positions of specific stars as seen from Earth. 10 million years ago, those stars were in different positions relative to us, and the sky looked completely different. 10 million years from now, it will look completely different again. The constellations are not permanent features of the universe. They are temporary alignments created by the current positions of nearby stars relative to our current position, and both our position and the stars' positions are changing constantly. This is a strange thing to sit with. The star patterns that human beings have named, mythologized, used for navigation, woven into stories and calendars and religions. These patterns have only existed in their current form for a tiny fraction of Earth's history. Our ancestors, 100 million years ago, would have looked up at a night sky that we would not recognize at all. The stars would have been there, or some of them, but their arrangements, their relative brightnesses, the patterns they formed, all of it would have been different. The universe had a completely different face then. And our distant descendants, if they exist 100 million years from now, will look up at a sky equally different from the one we see tonight. Orion will be unrecognizable. The Big Dipper will have dissolved. New patterns will have formed, and those future humans, if they exist, will have their own names for them, their own mythologies, their own navigational traditions built around stars that we have never seen in quite those positions. The sky is not a fixed backdrop. It is a slowly rotating, slowly shifting landscape that changes as the solar system moves through the galaxy. What we see when we look up tonight is a snapshot, a single frame from a very long film, and the film has been running for 4.5 billion years, each frame slightly different from the last. The solar system spiraling through new regions of the galaxy, presenting new views of the stellar neighborhood with every million-year increment. There's one more dimension to the solar system's motion that we haven't talked about yet, and it's one that connects the very large to the very small in a way that I find genuinely wonderful. It's the question of what the sun's motion means for the interstellar medium, the thin gas and dust that fills the space between stars. The solar system is not moving through empty space. Interstellar space is filled with a very thin gas, mostly hydrogen, with traces of other elements. It's extraordinarily sparse, far better than any vacuum we can create in a laboratory on Earth, but it's not nothing. And as the sun moves through this gas at 230 kilometers per second, it creates a kind of bow wave, a disturbance in the interstellar medium caused by the solar system's passage. The solar wind, the constant stream of charged particles flowing outward from the sun, creates a bubble around the solar system called the heliosphere. The sun's radiation and magnetic field dominate the environment inside this bubble, protecting the planets from the direct impact of the interstellar medium. The boundary of this bubble, where the solar wind meets the interstellar medium, is called the heliopause. Voyager 1 crossed the heliopause in 2012, becoming the first human-made object to enter interstellar space. Voyager 2 followed in 2018. Because the sun is moving through the interstellar medium, the heliosphere is not a perfect sphere. It's compressed on the side facing the direction of travel, where the solar wind is pushing against the oncoming interstellar gas, and extended on the other side, where the solar wind blows out into a long, trailing tail. The heliosphere has a shape a bit like a comet, with a rounded nose pointing in the direction of the sun's motion through the galaxy, and a long magnetotail stretching behind. The path is a helix. The helix winds through the galaxy. The galaxy flows through a supercluster. The supercluster is part of a universe that has been expanding since the very first instant of time, and somewhere on one small loop of that helix, on one tiny planet orbiting one ordinary star, something happened that has never happened anywhere in the neighborhood for at least 4.5 billion years. That something is aware. It can look up at the sky. It can measure the motions of distant stars and deduce where it is going. It can understand, not just sense, but genuinely understand, the nature of the journey it is on. It can feel wonder at the scale of it all, and it can try, imperfectly but earnestly, to share that wonder with other aware things. That's what we've been doing here tonight. And the journey continues at 600 kilometers per second into regions of the galaxy no part of us has ever visited before. We are not on a planet sitting still under the stars. We are on a planet spiraling through them, and there is no moment when we are not moving forward, no moment when we are not somewhere new, no moment when the universe is not bigger and more extraordinary than the last diagram we drew of it suggested. Take a moment tonight to actually sit with that. Step outside if you can. Look up at whatever stars are visible from wherever you are, and know that you are moving through them, not looking at them from a fixed address, moving through them at impossible speed, on a path that curves through the galaxy in a helix that has never been traced before and will never be traced again. Each moment of your life has been spent at a unique location in the galaxy. No one who ever lived was exactly where you are right now, because where you are right now has never existed before. The solar system is not a picture on a classroom wall. It's a voyage, and you are on it. If this journey through the real nature of our cosmic home is something you want more of, a like and a subscribe is genuinely one of the best ways to help make sure we can keep going. And the next time you see that flat diagram of the solar system in a textbook or on a poster, you'll smile a little, because you'll know what it's not showing. You'll know the whole truth is stranger, more beautiful, and more astonishing than the simplified picture could ever capture. Good night, and safe travels. You're already farther than you think. But let's not stop there, because there's one more thing the flat diagram hides, and it might be the most counterintuitive of all. It has to do with what an orbit actually is, at the most fundamental level, and why the helical picture forces us to think about it differently. In the textbook, an orbit is explained as a balance between two forces: the planet's tendency to fly off in a straight line, its inertia, and the sun's gravitational pull dragging it inward. These two things balance each other, and the result is a curved path, an ellipse. That's a useful way to think about it, and it's not wrong. But there's a deeper way to understand orbits that comes from general relativity, Einstein's theory of gravity. And once you understand it, the helix takes on a whole new meaning. In general relativity, gravity is not really a force at all. Objects in space don't curve their paths because a force is pulling on them. They move in straight lines. The catch is that what counts as a straight line depends on the geometry of space-time, and mass curves space-time. The Earth, orbiting the Sun, is actually moving in what relativity calls a geodesic, the straightest possible path through curved space-time. From inside the geometry, the path looks straight. From outside, it looks curved. The orbit is a straight line in curved space. This means that the Earth is, in a very real sense, always moving in a straight line. But the straight line curves because space itself curves near the Sun. And the Sun is always moving in a straight line too, the straightest possible path through the curved space-time of the Milky Way galaxy. And the galaxy is moving in the straightest possible path through the curved space-time created by the larger structure of the local group, and so on up the chain. Every helical path, every orbit, every spiral we've described tonight is a straight line in curved space-time. The curves are not deviations from straight. They are straight in the geometry that actually governs the universe. This is perhaps the most mind-bending consequence of general relativity for everyday thinking about motion. There are no curves. There is only curved space and straight lines moving through it. When you look at the helix traced by Earth through the galaxy, you are looking at a straight line in curved space-time. It looks like a spiral to us because we're trying to map it onto flat Euclidean space, the kind of space our intuitions are built for. But in the actual geometry of the universe, it's straight. Earth is going as straight as it possibly can, every moment of every day, following the geodesic through the curved space-time in which it finds itself. And so are you. Every movement you make, every fall, every orbit, every cosmic journey is the straightest possible path through whatever geometry of space-time you happen to be embedded in. The universe doesn't pull things off course. It curves the course itself, so that what looks like deflection from outside is from inside, perfect, unswerving straightness. This is why the motion of the solar system through the galaxy doesn't feel like motion. We are following the geodesic. We are going straight. The galaxy curves around us, in a sense, or more precisely, we are moving through the curvature of the galaxy in the way that minimizes the distance traveled through space-time. There is no force pushing us sideways. There is no engine driving us through the Milky Way. We are simply falling freely along the straightest possible path through a universe that is not geometrically flat. We are falling toward the center of the Milky Way's gravitational pull, and the angular momentum of the solar system's formation prevents us from simply dropping straight in, so we orbit. We are falling toward Andromeda, slowly, and in about 4.5 billion years that fall will become a collision. We are flowing toward the center of Laniakea, carried by the large-scale geometry of the local universe. All of this is falling. All of it is free motion along geodesics in curved space-time. The solar system is not being driven through the galaxy by any engine. It is falling through the galaxy freely, along the straightest path available. And that path, mapped in three-dimensional space over time, is the glorious, complex braided spiral of helices that no textbook diagram has ever shown you. There is something deeply calming about this, once you sit with it. We are not fighting the universe to stay where we are. We are not being flung through space against our will. We are following the path of least resistance through a curved space-time, which is the most natural thing in the universe, which is precisely what every particle of matter does at every moment. We are in free fall, all of us, always, falling through the galaxy at 230 kilometers per second, following the geodesic, going perfectly straight through a universe that only looks curved because we keep trying to map it onto a flat piece of paper. The direction the sun is heading, the direction toward which the nose of the heliosphere points, has a name. It's called the solar apex, and it points toward a region of the constellation Hercules, near a star called Vega. This is the direction from which the interstellar medium appears to blow toward us, the headwind of our galactic journey. When you look at the constellation Hercules, you are looking toward the direction the solar system is coming from, the direction from which our cosmic journey has been advancing. Looking in the opposite direction, toward the constellation Columba, roughly, you see the direction the solar system is heading away from. This is the solar antipex, the direction of our wake as we move through the galaxy. These directions have been known to astronomers for centuries. The movement of the sun through space was first detected in the 18th century by William Herschel, who noticed that the nearby stars appeared to be spreading apart in one region of the sky and converging in another. This pattern, like the way trees appear to spread apart in front of you and close behind you as you walk through a forest, is the signature of the sun's motion through the stellar neighborhood. Herschel correctly identified the solar apex from this pattern, recognizing that the sun was moving toward Hercules long before spacecraft had ever left the Earth. So for over 2 centuries, astronomers have known that the sun is moving. It's not a new discovery. It's not a secret. It's simply a fact that doesn't make it into the standard flat diagram because the diagram is designed to show orbital structure, not galactic kinematics. And it's a fact that changes everything about what the solar system actually is when you think about it deeply enough. Let's pull back one more time and think about what all of this tells us about the nature of the solar system as a structure. The flat diagram presents the solar system as a stable, orderly arrangement. The sun at the center, the planets in their lanes, each one on its predictable path. And there's truth in that. The orbital mechanics of the solar system are extraordinarily stable. The planets have been in roughly their current arrangement for billions of years, and will remain so for billions more. The clockwork precision of planetary motion is real and it's beautiful. But the solar system is not just an arrangement. It's a traveler. It has been moving through the galaxy since it formed 4.6 billion years ago, visiting different regions, experiencing different environments, carrying with it the entire inventory of planets, moons, asteroids, comets, and the life on at least one of those planets. It has passed through different arms of the spiral galaxy. It has bobbed up and down through the galactic disk. It has swept through clouds of interstellar gas and regions of relative emptiness. It is, in every meaningful sense, on a journey. And we, on this small, rocky planet in the inner solar system, are passengers on that journey. We have always been passengers. We were passengers before our species existed, before life existed, before the planet itself existed. The molecular cloud that collapsed to form the solar system was already part of this galactic journey, already moving through the Milky Way. We inherited our motion from the matter that formed us, which inherited its motion from the matter that formed it, which ultimately traces back to the original motions imparted by the Big Bang itself. There is an unbroken line of motion from the birth of the universe to you, sitting here right now, moving at 600 kilometers per second through the cosmos. Every atom in your body has been in continuous motion for 13.8 billion years. Not once in all that time has any of that matter been truly at rest. Rest, in the absolute sense, does not exist in this universe. Everything moves. Everything has always moved. The illusion of stillness is just what happens when everything around you moves with you. The flat diagram of the solar system was never really wrong about what it was trying to show. The orbital structure it depicts is real. The relative positions and motions of the planets relative to the sun are accurately represented by those concentric ellipses, but it was always showing you one layer of a much richer, much more dynamic reality. A reality in which the solar system is not a fixed mechanism, but a moving structure. Not a static arrangement, but an ongoing journey. Not a place, but a path. The flat solar system diagram was never going to capture this. It was designed for a different purpose, and it serves that purpose well. But reality is not a flat diagram. Reality is curved space-time, and the solar system is a structure falling through it, spiraling, winding, advancing into territory it has never occupied, drawing a path through the galaxy that is both a helix and a straight line, depending on which geometry you use to describe it. Both descriptions are true. The helix is true in flat space. The straight line is true in curved space-time. And both of them are more accurate, more complete, and more wonderful than the picture of a stationary sun with planets going around it in circles on a flat page. The solar system is moving. You are moving with it. Every second of every day, you are somewhere in the galaxy you have never been before. And every second of every day, you are going perfectly straight. The sky above you tonight is not a ceiling. It is the inside of the galaxy you are flying through. The stars are not fixed points. They are other travelers, each on their own geodesic through curved space-time, each tracing their own helical path, occasionally passing close to others, occasionally colliding and merging, occasionally ending in the quiet cooling of a white dwarf or the explosive brilliance of a supernova, but always moving, always falling forward, always going as straight as the universe allows. And somewhere among them, one small yellow star is carrying 8 planets through a region of the Orion arm of the Milky Way in a path it has never taken before. One of those planets is spinning on its axis while it orbits. One small part of that spinning planet is home to life that has become aware enough to ask where it is going. And the answer, as best we can determine, is forward, into the galaxy, along a helix, in a straight line through curved space, at 600 kilometers per second, with no destination, no end point, no return, just the ongoing journey that began when the universe itself began, and that continues every moment we are alive to notice it. I find that extraordinary. I hope you do too.